Okay, so we're going to use what we learned from differentiating from first principles to differentiate a function raised to a power. So hit pause, copy the objective down. When you're ready, hit play, and we'll look at some examples. So let's look at our rules of differentiation. So if y is equal to x to the power of n, that means that dy over dx is equal to n times x to the power of n minus 1. And if y is equal to a, which is a constant, times x to the power of n, then dy over dx is given by a times n x to the power of n minus 1. So those are the rules we're going to use today. It's worth noting though that you might sometimes be presented with a different notation where instead of y, we get f of x. Y is equal to f of x. So it's exactly the same thing. If f of x is equal to x to the power of n, then we say f dash of x is equal to n x to the power of n minus 1. Same rule, different notation. And if f of x is equal to a x to the power of n, then f dash of x, the differential of x of the function, is given by a n x to the power of n minus 1. So hit pause, make some notes on the rule, and we're going to look at some examples now. Okay then, some examples. Find the derivative f dash of x when f of x is equal to, so we do a, f of x is equal to x to the power of 6. When we differentiate it, f dash of x gives us, we take the power, 6 times x to the power of 6 minus 1 is 5. Let's try the next one, b, f of x is equal to x to the power of a half. So its derivative is going to be given by we take the power, so we multiply the power with the power, 1 over 2x, and then we subtract. So a half minus 1 gives us minus a half. We can rewrite that as equal to the reciprocal, so 1 over 2x to the power of a half, and to the power of a half means the square root, so that's equal to 1 over 2 root of x. Good. Let's try c. I think I've got enough room. F of x is equal to x to the power of minus 2, so if we differentiate it, we get minus 2 of x, and we take away 1, so minus 2 minus 1 is minus 3. For d, f of x is equal to x squared times x cubed. Just check with a pen. That's better. So our differential, well, x squared times x cubed is equal to x to the power of 5 by indices. So when we differentiate it, we get 5 times x, and then we subtract 1 from the power. 5 minus 1 is 4. And e, f of x is equal to x divided by x to the power of 5. So rule of indices tells us it's going to be 1 minus 5, so it would be x to the power of minus 4. And we differentiate that then. That gives us minus 4 x to the power of minus 4 minus 1 minus 5. So those are 5 examples differentiating f of x. Hit pause, take some notes, and we'll look at a couple more examples then. Okay, with these examples, we've got to find our derivative in terms of dy over dx. So let's do that. Just change pen. Right. For a, we have y is equal to 7x cubed. So dy over dx is equal to 3 times the 7, which is 21, x to the power of 3 minus 1 squared. Let's look at b. So we've got y is equal to minus 4x to the power of a half. So our constant stays the same, minus 4. Take our power, so we multiply it by the power. X to the power of a half minus 1 is minus a half. So that leaves us with minus 4 times a half is minus 2x to the power of minus a half. If it's minus a half, we can write it as minus 2 over x to the power of a half. And to the power of a half means the square root of. So equals minus 2 all over the square root of x. Okay, either of these 3 is valid. Personal preference would be this one, but it depends on the situation. Right, let's go on to C. Y is equal to 3x to the power of minus 2. So if we differentiate it, dy over dx gives us, take the power and multiply, so it'd be 3 times minus 2, x to the power of minus 2 minus 1 is minus 3. So we have minus 6x to the power of minus 3. Now, perfectly good answer, but you could write it as, depending if you needed to, minus 6 over x to the power of 3. Let's look at D. D, y is equal to 8x to the power of 7 divided by 3x. So we keep our constants the same, 8 over 3, and got x to the power of, because it's divided, we subtract, so 7 minus 1 gives us 6. We can differentiate now. Gives us 8 over 3, constant stays the same, times the 6, and it's going to be x to the power of 6 minus 1, which is 5. 3 goes into 6 2 times, so 2 times 8 gives me 16, so that would be 16 x to the power of 5. And we've got E. We got y is equal to the square root of 36 x cubed. Now I know the square root of 36 is 6, so I've got 6 times the square root of x cubed. I'm working with indices. Square root means to the power of a half, so I've got 6x to the power of 3 over 2, because it's to the power of a half, 3 over 2. Now I can differentiate. Dy over dx is equal to 6 times the power, 3 over 2, and x to the power of 3 over 2 minus 1 is a half. So that leaves me with 2 goes into 6. 3 times 3 is 9, so it's 9x to the power of a half, which is the same thing as 9 root x. Perfectly happy with this solution, perfectly happy with that. Good. So that's another 5 examples for you. Hit pause, copy them down, and we've got some classwork, exercise 12C. So not that many questions really. You've got question 1, 2, 3 and 4. So have a go. I'll leave you to self-select questions. I think you can do most of this in no time at all though.